This is Lesson 12, Modeling with Equations. In this lesson, we are going to learn how we can use math, or equations specifically, to model certain real-world occurrences or scenarios. Okay, some of you may think of this as basically how do we solve word problems, which is probably a simplistic way of looking at it, but in reality what we are talking about here is real-world problems and how can we use math to solve them. Now here's a strategy you should use when attempting to solve word problems or real-world scenarios using math. The first step is read the problem carefully. If necessary, read it again, even a third time. Don't assume anything. Read it carefully to make sure you understand what they are giving you, what they are asking you to find. Be very careful in reading it. Many mistakes are made when people either make assumptions as to what the problem is really asking, or don't really read and understand the problem. So step one is vital. Read the problem carefully. And in the process of reading it, make sure you understand what they are looking for and let that be your unknown or X, okay? So understand what are they looking for that you don't already know. That's going to be your unknown or X. Step 2. If necessary, write expressions for any other unknown quantities in terms of X. A lot of times in problems, you're given one major unknown, but you're given some other things in terms of that, like this other value is 20 more than what you're looking for, or something similar to that. So if there are other unknown quantities in the problem, express them in terms of the one unknown that you're looking for, okay? So write these in terms of X. Step 3. Write an equation in X that models the verbal conditions of the problem. Now this goes back actually to step 1, making sure that you understand what the problem is saying, okay? And basically what you have to do is you have to convert that into mathematical terms, into an equation, okay? So here's a case where you not only need to know the math, but you need to know the wording or the verbal nature of the problem so you can understand exactly what it's saying and then convert that to an equation that models those verbal conditions. Step 4. Solve the equation and answer the problem's question, okay? So step 3, we wrote an equation in terms of X. Now we're going to solve that equation for X, and we're going to state that as our answer and add any units that might be necessary. If we're talking dollars, if we're talking distance, whatever we're talking, add the units. And basically what we want to do here is at the end of step 4, you need to have answered the question that the problem posed for you. And lastly, step 5, check the solution in the original wording of the problem, not in the equation obtained from the words. So we want to go back to the original problem. Basically what you're trying to do is, one of the things you're trying to do is to find out, does your answer make sense? If you're asking for the distance between New York and Los Angeles, and you come up with 100 miles, this does not make sense, even if that is the actual solution of your equation. Your equation is wrong. So basically, you need to look at the solution. Does it make sense? Does it answer the original wording of the problem and not necessarily the solution of the equation? Because basically what you're doing here is you're checking the solution as well as the equation. Okay? So here are your 5 steps for solving word problems. Step 1, read the problem carefully, several times if necessary. Step 2, If necessary, write expressions for any other unknown quantities in terms of x. Step 3. Write an equation in x that models the verbal conditions of the problem. Step 4. Solve the equation and answer the problem's question. And lastly, step 5. Check the solution in the original wording of the problem, not in the equation obtained from the words. Okay? So let's look at an example here and put these steps to use. So here's a typical example, and it reads, the length of an American football field is 200 feet more than the width. If the perimeter of the field is 1,040 feet, what are its dimensions? Okay, so we need to read the problem carefully and understand what is it asking. Well, first of all, we're talking about a football field, and not a European football field, which you might think of as a soccer field. This is an American football field, okay? And we're asked to find the dimensions of the field, okay? So we want to know the length and the width. We're told the relationship between the length and the width, and we're told the perimeter. But we're asked to find what are the dimensions. Okay, so the first thing I'm going to do is determine what am I going to set x equal to. Well, I could let it equal either length or width. That doesn't matter. I'm going to let it equal the width. So the conclusion of step 1 is I'm going to let x equal the width of the field. All right. Now, step 2 is, are there any other unknown quantities that you know in terms of x? Well, yes, there's the length of the field. And if we go back to the original equation, the original problem, it says the length is 200 feet more than the width. So therefore, x plus 200 is going to equal the length. So now we have completed step 2. We have identified the unknowns and identified both of them in terms of x. So the width of the field is going to equal x. The length of the field is going to equal x plus 200. Now we need to move on to step 3 to come up with an equation. Well, if you think about this, what are we talking about? We're talking about a rectangle. Now here's a case where it's probably a good idea to draw a picture. So let's draw a rectangle, and now on this picture let's represent the width and the length of the field. So we know the width is equal to x, right? So we're going to say that this side here is equal to x, and this side here is the length, and this is equal to x plus 200. Well, what do we know about the opposite sides of a rectangle? We know that the opposite sides of a rectangle are equal, so this side here is also equal to x plus 200. And then the last side here is the opposite x, so this is also equal to x. All right? Okay, so what do we know about the definition of the word perimeter? Perimeter is the distance around something. So therefore the perimeter would be equal to x plus 200 plus x plus 200. It's the sum of all the sides. And what do we know about the perimeter? Well, if you go back to the original problem, it tells you. It says the perimeter of the field is 1,040 feet. So this should tell you what you're going to get for an equation. And your equation is going to look like this. So we've got 2 times the width is x, so that's 2x, plus 2 times the length, and the length is x plus 200, and we're told from the problem that the perimeter is equal to 1,040. So 2 times x plus 2 times x plus 200 equals 1,040. So this is the equation we're going to use to solve this problem. So if we get rid of the parentheses, we end up with 2x plus 400 equals 1040. Well, now if we combine like terms and subtract 400 from both sides, we should get, and this yields 4x equals 640, and now if we solve for x comes out equaling 160 feet. Now, so that's what we get for the width of the field. Now the length of the field is simply x plus 200, and the length therefore would be 360 feet. So the answer we've come up with for the dimensions of the field are 160 feet wide by 360 feet long. Now we have one last step, and that is we must look back and check this solution in terms of the wording of the original problem. Okay? Does this number make sense? Well, it seems to make sense here. All right? We have a width, which is 160. We have a length, which is 360, which is 200 feet more than the width. And that's from the original wording of the problem. Now, what else did it say in the problem? It said the perimeter was 1,040 feet. Well, if I add 160 plus 360 plus 160 plus 360, what do I get? I think you're going to find that you get 1,040 feet. So therefore, this answer does check, and we indeed have used math and solved the problem by coming up with the dimensions of the field. They're 160 feet by 360 feet. Okay, now go to the worksheet for this lesson and try a few of the word problems that are there and see if you're able to solve them, and in the process maybe just lessen your fear of word problems. Because if there's two things that most students dislike about math, it's fractions and word problems. But hopefully by following these steps, you're going to be able to take and now be able to solve word problems and not be so fearful of them.